Okay, the second half, worksheet 7. Or not worksheet, but overview 7. Okay, so again, I got to figure out what to use on these problems. Okay, so if I'm reading problem number 5, and this time they look more like word problems because there's a whole lot of words here. Assume standard deviation 3.6. Okay, first of all, it's got a standard deviation. And it doesn't really say whether or not that's for the entire population or wherever they got it. So I just kind of wrote down S. I know I'm going to use it no matter what. So, okay, 120 workers, that's got to be N. And their average was 16.2. Confidence, 92%. Okay, I've picked all the numbers out. Construct a 92% confidence interval for the mean. Good, the mean. I just did not want to see the word standard deviation there. Mean. Good, I'm glad to hear it. Okay, so I need to use, okay, it's definitely not prop. I got some sort of sigma I got to use. All right, so I'm going to use Z. Stat, tests, Z interval. Sigma is 3.6. X bar is 16.2. N is 120. Sea level, okay, usually it's 0.95, but for some reason this one says 0.92, so I'll go with that. All right, calculate. 15.625, comma, 16.775, and I better get the error. 16.775 minus 15.625 divided by 2.575. Okay, the next one. Number 6. Let's see. First of all, I'm scanning. I don't see anything that says anything about sigma. Plus, I see the word proportion. Okay, good. Prop. Prop was easy. I don't even need a sigma. All right. So I'm going to use one prop Z interval. Stat, tests, one prop Z interval. X is 400. N is 1,000. Sea level is 0.95. Calculate. 0.36964, 0.43036. E equals plus or minus 0.43036 minus 0.36964. And divided by 2. 0.03036. Okay. All right. So now I'm ready to read question number 7. Okay, let's see. Use these data to compute a 95% confidence interval for mu. For the mean. Good. At least it's not that standard deviation formula. It's definitely a mean problem. Okay, well, it's not prop. And I'm sort of expecting, you know, a mean and a standard deviation. But it didn't give me a mean and a standard deviation because in real life that hardly ever happens. What happens is you get a list of numbers. Okay. So I took my one variable stats on these 4 numbers and came up with those things. All right. So that's where those are coming from. I had to do that by myself. Okay. It wasn't in the problem, but that's real life for you. All right. So, and there's only 4, n equals 4. I know it's not a prop. It has a standard deviation. So I'm going to go with T interval on this. Stat, tests, T interval, X bar is 0.99. SX is 0.032. And N is 4. And sea level is 0.95 and calculate. 1.93908, 1.0409 with an error of 1.049 minus 0.93908 divided by 2, 0.05091. Okay, that was number 7. Number 8, find the confidence interval for the population standard deviation. I didn't want to see the word standard deviation there, but there it is. Population standard deviation, a confidence interval on the standard deviation. All right, okay. So you're talking square root formula then, huh? Square root of, okay, apparently there was 27 randomly selected dates, so I'm going to have to go 27 minus 1. And the standard deviation, 5.86. This is the worst part. I gotta get out my table. Okay, at least it's at 95% confidence. Good. That means I'm going down those middle 2 columns. Let's see, down the point, well, start with the 0.975 column. Go down to 26, 13.844. Go down the 0.025 column. 41.923. Okay. All right. So 5.86 squared times 26. Okay, so my numerators are, that means 892.83. All right. 892.83 divided by 41.923 is 21 point something. Take the square root. 4.61. 892.83 divided by this 13.844. And then 64 point something, take the square root, 8.03. I am 95% confident that the real standard deviation is somewhere between 4.61 and 8.03.